All right. I'm expecting the test to be either really late next week, like Friday of next week, or early the following week. I think it's more going to lean towards early the following week. So, your journal entries are already posted. Now, it is part copying, part having to do some stuff on your own. So, I gave you guys pretty much example problems where I fill them in. That's what you copy. The ones that are blank, you have to do on your own. All right. So, that's why I try to give you at least one example, and then the blank would be very similar. All right. And that's for all of them. So make sure that you fill in the blank problems. You are responsible for filling in those blank problems, and you also need to copy what I wrote down verbatim. If you don't copy it exactly, I'm taking points off. So no shorthanding it, no simplifying it. You need to copy what's down there. All right. So that's what I expect you guys to do with your journal. And again, like about 70% of it's just copying. 30% of it is you solving those problems. All right. So you got a solid week to get it done. All right. So my recommendation, just do one a day and you'll be golden. All right. So that's already posted in Canvas. It's already linked there as well. All right. So let's go ahead and go over this warm up. So review from yesterday. First one, we're simplifying. Now, what's always the first step if you have a negative under that radical? Take the I out. So I have 3i times the square root of 243. What was the largest perfect square that went to 243? 81. So it's 81 and 3. So this would be 3i times square root of 81 is 9, square root 3. Now, remember, you can't add or subtract imaginary and real, but you can multiply them. So you can actually simplify that a little further. So this would be 27i square root 3. I think most of y'all got that, so good job. Now, this one, I asked you to find I raised to the 114th. Okay? Remember, always find the nearest multiple of 4 because I the fourth power is what? 1. So multiples of 4, if it's a multiple of 4, it's automatically 1. All right. So find the nearest multiple of 4. However many i's are left over, that's your answer. All right. So what is the nearest multiple of 4 to I the 14th? I the 12th. Or I to the 112. So that'll be 1. How many i's would you have left over? 2. So you do I squared. What is I squared equal to? -1. So 1 times -1, that's -1. All right. So today we're finally getting into solving land. All right. We are finally done with everything radicals and we're going into solving. So we're going to start with one that you're fairly familiar with or should be, solving by factoring. So this is going to actually take about 3 days because we have to review all of the factoring methods. All right. So go ahead and take out your packet and go to page, what page are you on, Richard? 11. So it should say factoring by GCF and grouping at the top. Now, for whatever reason, factoring by GCF, in my opinion, it's one of the easiest methods. However, it's also the one that most people screw up. All right? Because they either don't get the GCF or they forget that that exists. Especially if it's one of those where you have to take the GCF out first and then factor. All right? So we're going to really kind of hit hard on GCF. So first off, remind me again what GCF means? Greatest common factor. So we're going to look at all the terms to determine the GCF. Now remember, when it comes to factoring, you can either have three different options. You can have a number as your GCF, you can have a variable as your GCF, or you can have a mixture of both. All right, so make sure, because a lot of times I think most of the ones that y'all have dealt with is number GCFs, but you can in fact have variable GCFs. All right. So then you write out the GCF, that's one of your factors. You divide the GCF out of each term, put the quotient inside the parentheses. Should be fairly familiar with that. So let's look at this first one. All right. So 35 and 42. What is the numerical GCF there? 7. All right, so you can divide 7 into both of these. All right. Now, is there a variable GCF? No. Why? Right. 42 does not have an x, so there's no common variable. So we can stop at 7 as our GCF. Now, what's 35x divided by 7? 5x. 42 divided by 7? 6. So this is 5x plus 6. Now, to check yourself at the end, just make sure, ask yourself, okay, is there anything that 5 and 6 have in common? If the answer is no, besides 1, then you're done. So this would be your answer. What about this next one? What do you think the GCF is here? Okay, let's try 18. So, and there's no variable GCF because 54 doesn't have an x. What's 18x squared divided by 18? X squared. What's 72x divided by 18? 4x. What's negative 54 divided by 18? Negative 3. So it was in fact 18. Now let's pretend that you didn't know it was 18. Let's say you picked 9. All right. Here's how you can fix it. So let's just hypothetically, you don't necessarily have to write this down, but hypothetically, let's say you picked your GCF as 9, which it's not the GCF, it's just a CF or common factor. But it is usable. So if I divide 9 out, I get 2x squared plus 8x minus 6. Now, if you got that far, what's kind of the niggling in the back of your head that should tell you that you're not done? Well, it's possible to get a 2x squared and not have a GCF. They're all divisible by 2. All right. So just because the a value is not 1 doesn't mean that you have a GCF, that you still have a GCF. You will see some where the a value is 1, but there's no GCF at all. What should clue you in is that all 3 terms are divisible by 2. So you need to take out another common factor of 2. So when you do that, you multiply it to the already 9 outside. So that'll give you the x squared plus 4x minus 3. Clean it up a little bit. 9 times 2, that's 18. So it does happen occasionally where if you pick the wrong number or you don't go high enough, that happens. It doesn't mean you have to start over. It just means you got to take another thing out and multiply it to what you already have outside. All right? Does that make sense to everyone? Now, these next ones are going to have some variable GCFs. So what I always recommend to students is go one subtype at a time. with your GCF. So let's start with numbers. What is the numerical GCF of 35 and 45? 5. Now, what do you think the GCF is of the x's? X squared. So, little trick when it comes to your variable GCFs. Whatever the lowest exponent is between the two sets of pairs of variables, that's the GCF. So if the lowest is exponent is a 1, it's just x. If it's a 2, it's x squared, so on and so forth. All right? So you don't have to do too much of a think about that GCF. You just take whatever the lowest exponent is. What about this last one? The y's. Y squared. So my GCF is 5x squared, y squared. So when you divide, again, you just divide each at a time. So what's 35 divided by 5? X squared divided by x squared? 1, so we don't have to write anything. Y cubed divided by y squared? Y. Plus, what's 45 divided by 5? 9. X cubed divided by x squared? X. Y squared divided by y squared? 1. Do 7 and 9 have anything in common? Nope, so we're done. So you just got to take it one step at a time, all right? And then even with dividing it, just so you don't confuse yourself, especially if you're one of those where you can't just look at it and see what it'll be, just do it one piece at a time. Try the next one on your own. So example 4, try it on your own. Thumbs up if you're ready. Give you one more minute. When you finish, compare answers with your group mates. Alrighty, check your answer. All right. Shh. Any questions on this one? All right, so let's talk about this. First off, be honest. How many of y'all had a little bit of trouble finding the numerical GCF? Kind of, sort of. Okay, here's kind of a trick to do it if you're having issues or if it's like a bigger number than what you think it would be. So your calculator can actually calculate GCFs for you. The only downside is it can only do 2 numbers at a time, but you can kind of play with it to figure it out. So if you hit the math key, which is right underneath the green alpha key, then you're going to hit the arrow key, the right arrow key, to hover over num. And you're going to scroll down using the down arrow key until you see GCD, which should be at 9. GCD stands for greatest common denominator. It's the same thing as a GCF. And then you hit enter. Now, pick 2 of the numbers. So I'm going to do 24 and 36. I'm going to do 24, comma. The comma key is right next to the parenthesis key. It's to the left of the parentheses. 36. And hit enter. Now, the GCD of that one is 12. So, to double check, pick a different pair of numbers. So you don't have to go back to type in GCD. Here's a little trick. If you hit second and then enter again, it re-enters what you originally put in. And then you can go back and change what you need to change. So let's change the 24 to 54. That one's 18. Okay, still not quite there. So let's do one more time. So let's do 24 and 54 together. So second entry, I'll do 54 and 24. So that one's 6. You pick the smallest one. All right. Because if 54 and 24, it's 6, but the other 2 are higher, that means that they won't be able to. So, like, for example, 18 cannot be divisible by 24. 54 cannot be divisible by 12. So if you take those 2 together, you get 6. Now, Desmos will actually do all 3 at the same time. Numworks, I haven't played with that one. I'll get back to you on that one. Desmos can do all 3 at the same time, but remember, you won't always have access to Desmos in this class. So I'll show you how to do it in Desmos, but just know, at the very least, you'll more often than not have at least a calculator. All right? You may not always have Desmos, but I will show you Desmos anyway. So if I open up Desmos, you go to the function key, and you scroll all the way down to the very bottom where it says number theory. Do you guys see where it says GCD right here? If you click it, all right, and you can type in all 3 numbers. Make sure you separate them by comma. So 24, 36, 54. It is, in fact, 6. So Desmos will do all 3. The calculator will only do 2 at a time. Trust me, I've tried. It'll give you an error if you try to put all 3 in. Yeah. So that's just a strategy that you could use. As for the numworks, I'll play with it. I haven't done that one yet, but I'll play with it and get back to you on that one if you want to know. All right. Now, how many of you were having issues with finding the numerical GCF? Not the numerical, the variable GCFs. Be honest. Speak now, forever hold your peace, because I'll go over it. Yes. See how this N is by itself? It's in the first. just like how over here the p's by itself. So even though it's like connected to the p squared, the squared's only affecting the p because there's no parentheses around the np. So that's why it's only a singular one. So remember, for variable GCFs, you look at each letter and you ask yourself, okay, does everyone have an M? Does everyone have an N? Does everyone have a P? If it's yes to all three, then it's like, okay, what's the highest exponent? Or sorry, what's the lowest exponent for M? What's the lowest exponent for N? What's the lowest exponent for P? You got your variable GCF. Now, if at least one term does not have a letter, so let's say, for example, the last term didn't have a P, then P would not be part of your GCF. All right. Any questions? All right. The next one is factoring by grouping. So typically we factor by grouping for polynomials with 4 terms. So typically when you factor by grouping, they're not necessarily quadratic. Sometimes they're cubic. All right. You'll see more of like the quadratic grouping when we get to factoring trinomials. But you would split the problem into 2 pairs. So you group the first 2 and the last 2 together. You take the GCF out of each pair. The parentheses will match, and you pull this out of the problem like a common factor. And your answer should be the product of 2 binomials. So these steps right here are describing what I call the T method, which you'll see why I called it that in a second. Another one is, I like to call it the reverse box. So when it comes to factoring, I like to give you guys options because honestly, there's more than one way to skin a duck. All right. So this, like, some people like the T method better. Some people like the reverse box method better. I don't care which method you pick, as long as you can do one of them well and correctly. To each their own. Whichever one you're the most comfortable with, feel free to use it. So reverse box method is literally, you make a box like you're going to do box method, but you would put your first term in this box, top left always, your last term here, so the fourth term here. And the second and third can go in either or of these. It doesn't matter the order. So you can put the second here, third here, or you can put the third here, second here. It doesn't matter. As long as first term goes in top left, last term goes in bottom right. Then what you do is you take the GCF of each row and the GCF of each column. And what it will do is it'll actually give you the factors at the end. So I'm going to show you guys both ways. All right. And you can decide which one you like better. All right. But I'm going to show you guys both ways just to give you guys options. So we're going to start with the T method. This is kind of the original way to solve by group, not solve, factor by grouping. So for my grouping, it's very, very simple. I just draw a line right there. So I just draw a line in between the second and third term, making sure that the third term sign is with the third term. And this is why it's called the T method, because I like to draw a line underneath it. Now, we have 2 groups, here and here. What is the GCF of the first group? X squared, good. So I'm going to divide both of these by x squared. That's why I drew the line. So I have x squared times, what's x cubed divided by x squared? X. X squared divided by x squared? 1. So plus 1. Now, the second group. What I always tell my students is whatever the sign is of the third term is, bring it down. And that'll be part of your GCF. So our GCF is going to be positive. Where this comes in handy is when you have a negative GCF. All right. So, what's my GCF of this group? 2. So I'm going to divide both by 2. So I'm going to write 2 here. Make sure you write your GCFs on the outside. What's 2x divided by 2? X. 2 divided by 2? 1. Now, we know if we're correct if these two bubbles are exactly the same. So those two bubbles have to be exactly the same, signs and all. All right. We know we did correctly. Those bubbles are exactly the same. Also, whatever is in the bubble or whatever's in both of the bubbles, that is also one of your factors. So one of our factors is going to be x plus 1. Now, what I like to do is once I deal with the factor that's in the bubbles, I just cross it out, just so I know that I'm done with it. Whatever is left over, that goes in my second bubble. So what's going to go in my second bubble? X squared plus 2. That's it. You can't factor it anymore. All right. So that was the T method. All right. That's the T method. Now, we're going to do the same problem, but I'm going to do the reverse box method. All right. So, first things first, I'm going to set up my box. Now, remember, your first term always goes in the top left, so this would be x cubed. Your last term will always go in the bottom right, so that will be a 2. And then the middle terms, you can put in either or. So I'm going to put the x squared here and the 2x here. If you flip-flop the x squared and the 2x, it's okay. You'll get the exact same thing, regardless. But first term has to be in top left, last term has to be in bottom right. You just got to remember, first in top left, last in bottom right. Otherwise, it doesn't work. All right. Now, we then are going to take the GCF of each row and each column. So what's the GCF of that first row? X squared. What's the GCF of the second row? 2. What's the GCF of this first column? X. What's the GCF of the second column? If it doesn't have a GCF, what do you always put? 1. And then right here is both of my factors. So if we write them out, x squared plus 2 times x plus 1. We get the exact same thing. And remember, no matter which way you write it, whichever factor you write first, remember multiplication is commutative, so you can flip-flop them. Yes, Eisen? Yes, sir. So to be honest, I've done factoring enough that I don't necessarily use a method every time, but I kind of lean more towards reverse box because I just like the visual of it. But I can also do T method pretty well, but that's just because I've been doing it forever. So when I was in school, T method was the way that I learned. So I didn't actually learn reverse box until I started teaching, but I kind of like it a bit more than T method. But again, to each their own. It's whichever one. I just say try both. Like maybe switch up. Just try both and see which one you like better. That's kind of the way to go about it. All right, let's try another one together. So, which method do you want me to do first? T or reverse? All right, I'll do T first. So, I'm going to draw my lines to make my T. All right. So, what's the GCF of the first group? 2a squared. All right, that's my GCF. So I'm going to divide both by 2a squared. So I'm going to put 2a squared on the outside. What's 4a cubed divided by 2a squared? 2a. 4 divided by 2 is 2. A cubed divided by a squared, you had 3 a's. You took away 2. You have 1 left. What's 10a squared divided by? Yes. Yeah. What's 10a squared divided by 2a squared? 5. Now, remember, whatever the sign is of your next group that starts your next group, you need to bring it down. So your GCF is going to be negative for your next GCF. All right. Because if you don't factor out the negative, what's going to happen is that the signs will be different between the two bubbles. All right. So that's why I say whatever the first sign is of the group, bring it down. And that will tell you what needs to go in your GCF. All right. So besides the negative, what do the 6a and 15 also have in common? 3. So our GCF is going to be negative 3. So we're going to divide both of these by negative 3. So what's negative 6a divided by negative 3? 2a. What's negative 15 divided by negative 3? Plus 5. Since the bubbles are the same, we did it correctly. So again, that's why I tell you to bring down that first sign of the second group, because it forces you to take the negative out. Mainly where a lot of kids run into trouble, like the way I've taught it previously, where kids will recognize the 3 but not the negative, and then I have to tell them, okay, well, now you got to take the negative out because the signs are different. This is just easier. It's easier to remember. All right, less room for error. So what is guaranteed one of my factors? 2a plus 5. Again, you don't have to do this, but I like to just cross them out so I know I'm done with them. And what do I have left over? 2a squared minus 3. And we're done. So again, that was T method. Now, let's say you wanted to do it reverse box. So I'm going to do a reverse box. And again, I'm only going to do this for these two. For the rest of the examples, I'm just going to pick one or the other. But just so you guys kind of get a feel for how they look for both. All right. So I'm going to draw my box. What goes in the top left? 4a cubed, so the first term. What goes in the bottom right? Negative 15. And then the other two terms you can put in the other two boxes, and it doesn't matter their order. If you flip-flop the 10a squared and the negative 6a, it's okay. And then you're taking the GCF of each row in each column. So what's the GCF of this first row? 2 what? A squared, good. Now, this next row, all right, same thing. If the first box in that row starts with a negative, you need to take the negative out. So if the first box in a row or column starts with a negative, you need to take it out. So I'm taking out negative what for the next row? 3. Then I want to do this row, or this column, I mean. What's the GCF of the first column? What's the GCF of 4 and 6? 2. What's the GCF of a cubed and a? A. And then what's the GCF of the last column? Plus 5. And if we pull them out, don't we get the exact same thing? So 2a minus 3, 2a plus 5, isn't that the exact same thing? Yep. So again, it's just whichever one you're most comfortable with. I have students in my first period who's also math 2. They're just not honors, but my first period honestly prefers reverse box over T method just because it's more organized. All right. Again, each one has their advantages. Each one has their disadvantages. It's depending on what you like the most. Whatever makes the most sense to you, that's what you use. All right. Okay. Take a second. Try those two on your own. Mhm. So it's not good negative. That was good news. And this one, that was the X. So 4x equals 45 by x equals x. We have 45. So that's x. For x. This one, because we have GCF means we each have to have one. So this needs to be done with x. Then you can take it and have negative. Yeah. So this is negative. So you should have negative x one, negative x one. So guys, maybe try one method for one and then another method for another. First. So this is so it's just the first. Just remember first negative. Second can be negative all at once. So which method? So okay, so what's on this side?
Well, I know, like I know how to do it. It was just how, like, because like 2x that would be 2x, right?
No.
Two.
You both trying to divide by 2?
Oh, yeah, it's x on both sides.
No, just x.
X.
Yeah. So that's like what 3 is. And again, that's what
No, I just, no, I
thumbs up if you're ready, guys. Give you 1 more minute.
Jesse. That was wearing that actor.
All right, my darlings, let's go over this. So I'm going to do T method for the first one, reverse box for the second one, just to get some variety. All right. So T method for the first one. Remember, regardless of which method you use, you should get the exact same thing. All right. So I draw my separation. And remember, the vertical line is what's actually grouping it. So you got this one and this one. So what's the GCF of my first group for the yellow one? X squared. So numerical, there is none besides one, because this one doesn't even have a coefficient. And then variables, since they both have x's, you look at the lowest exponents. So if I divide both of these by x squared, what's 2x cubed divided by x squared? Nope. What's 2x cubed divided by x squared? 2x. And then x squared divided by x squared is 1. Now, what did I tell you to do for the next group? Bring down the first sign. So your GCF is going to be positive. Now, is there a GCF there? No. So if there's not, then you say 1. So if there's no GCF, you don't just leave it blank. You got to say 1. So that's 2x plus 1. These match, so we're good. So that means one of my factors is absolutely what? Was absolutely positively one of my factors. 2x plus 1. I can cross those out because I'm done with them. What's left? X squared plus 1. And there it is factored. If you did reverse box, you should have gotten pretty much the exact same thing. Any questions on 7? All right, 8, I'm going to do a reverse box. So I'm going to draw my box. What goes in the top right? 5x to the fourth. Sorry, I meant top left. Top right. Oh my God. It's Friday, y'all. Bottom right. What goes there? 1. So first term in the top left, bottom right's the last term. And then you fill in the other 2 boxes with the other 2. And again, it doesn't matter if you flip-flop the 5x cubed and the negative x. It's fine. You'll get the same thing. Then you just go through GCF. So what's the GCF of my first row? 5x, not squared, cubed. All right. What's the GCF of my second row? And take into account what the first box sign is. -1. So since the first term is negative in the row, you have to pull out a negative. They have nothing else in common, so it's a 1. What's the GCF of my first column? X. What's the GCF of my second column? Make sure you look at the sign of the first box. -1. So if I pull these out, it would be 5x cubed minus 1 times x minus 1. Now, guys, you don't have to circle the rows and columns. I'm just doing it so you can tell which one I'm talking about. All right? But the circling is what's kind of like messing with you. You don't need to do that. Just if you can see it, it's fine. All right. Any questions on the... Yes. For that one? Sure. Okay, so this would be 5x to the fourth minus cube minus x plus 1. All right, so I'm going to draw my line, making sure to include the sign of the third term with the third term. What's my GCF of the left group? 5x cubed. If I divide both, I get x minus 1. Now, what did I tell you to do with the second group? Bring down that first sign. So your GCF is going to be negative. So what's the GCF of the second group? -1. So that means I have to flip-flop both of these signs. So this negative x becomes x, this positive 1 becomes negative 1. Both of these are the same. I absolutely have x minus 1 as one of my factors. I can cross them out. What am I left with? 5x cubed minus 1. Does that answer your question? Yes. Yeah. Put your name on the board. So regardless of the method, you should get exactly the same thing. Again, it's whichever one makes the most sense to you. All right. Now, last thing we got to talk about is the solving aspect. So, zero product property. All it states is that if you have a times b is equal to 0, where a and b are some number, then either a has to be equal to 0 or b has to be equal to 0. So in other words, one of these two have to be 0. Why is that true? Any number times 0 is 0. So at least one of these terms have to be 0. We just don't know which one. That property is the reason why when we solve by factoring, we set both factors equal to 0. All right, because when we solve a quadratic, we have to set it equal to 0. Because remember, we're going for the x-intercepts, so the y has to be 0. All right. So that's why when we factor, we start with ax squared plus bx plus c equal to 0. Because remember, the x-intercepts are our solutions. So x-intercepts are written as some number and 0, while our output is 0. That's why we set equal to 0. So when we factor, we set both of those terms equal to 0, because if this equation equals 0 in the end, that means one of those factors will have to equate to 0. I know I said a lot of zeros in that sentence, but did that kind of make sense? Well, you'll see in a second. So when it comes to factoring, you bring all the terms to one side of the equation in descending order, with the first term being positive. So in other words, rewrite it so it looks like that in some shape or form. You factor completely, and then you use the zero product property to solve. In other words, set both factors equal to 0, including a variable GCF. So don't forget to set the variable GCF equal to 0 as well. Now, numerical GCF, don't care. Doesn't affect anything. The variable GCF, however, that is part of the problem. So let's look at example 9. What do I need to move over to the other side to get one side equal to 0? The 3x. How? Subtract it. And remember, since x squared and 3x are not like terms, we can't combine them, so I have x squared minus 3x is equal to 0. Now, surprisingly, this is the kind of problem that most people struggle the most with. Like, I swear, on every test that I've seen with this problem is the one that consistently they get wrong. It's actually the easiest. All right? Because most people try, once you learn all the other methods, you just got them stuck in your head. And most people try to either do factoring a trinomial or factoring like difference of squares, whatever. When in reality, all you got to do is just take a GCF out. What is the GCF? X. So the GCF is x. So I'm left with x minus 3 is equal to 0. Now, here's where a lot of people mess up with this as well. This GCF is a variable, meaning it is considered a solvable factor. So we also have to set that singular x equal to 0. So I have to set both of these factors equal to 0. So I have x equal to 0, x minus 3 equal to 0. Well, x equal to 0, we don't got to do anything else with that. Solved. How do I solve x minus 3 equal to 0? Plus 3 on both sides. So x is equal to 3. So we write this, x is equal to the set of 0 and 3. And these are not parentheses. They're, I forget what they're called, but I just call it the squiggle bracket. Or just, whatever. I just call it the squiggle. It's easier to remember. It's just a squiggle. All right. Now, these problems at the bottom, some of them are already factored for you. Okay, so like for example, 19 through 22 are already factored for you. So you can just go ahead and set both equal to 0 and solve. So let's do 22 real quick. So if I set a minus 9 equal to 0 and 2a plus 1 equal to 0, how do I solve a minus 9? Add 9 to both sides. A is equal to 9. How do I solve 2a minus 1? Or plus 1, sorry. Subtract 1 first and divide by 2. So a is equal to negative 1/2. So a is equal to the set of negative 1/2 and 9. Any questions with solving by factoring? And that's true for any solve by factoring. You always set whatever two factors you have equal to 0, solve the mini equations. That's all you got to do. Honestly, the hardest part of solving by factoring is the actual factoring itself. The solving aspect, you're basically going to be solving like linear equations. All right, any questions? So you got a new Delta Math for homework. All right, you guys got a solid 15-ish minutes. You can at least get a little bit done of that. So go ahead and get to work on that.